the Philippine Navy (PN's) first two anti-submarine helicopters, the AgustaWestland AW-159 Wildcat, will be operational in detecting, and if necessary, destroy submersibles encroaching on the country's waters this November. The helicopters are okay and the crew is still undergoing training on how to operate the aircraft and its various systems. Our full anti-submarine warfare capability will be completed this year once the delivery of its weapons, torpedoes and missiles, are completed, along with the training of the Naval Air Group pilots selected to man the helicopters. I think the target date is November, PN Flag Officer in Command, Vice Admiral Robert Empedrad told a media interview on Wednesday night. Once these requirements are met, Empedrad said the AW-159s can locate hostile submarines and destroy them with torpedoes if needed. Earlier, the PN said the first batch of South Korean-made Lignex-1 Blue Shark lightweight torpedoes, which will serve as the primary weapon of the two AW-159 helicopters, arrived in the country last July. The AW-159 helicopters, which were delivered on May 7, 2019 and commissioned on June 17 of the same year, were acquired for 5.4 billion Philippine pesos, including its mission essential equipment and integrated logistic support. They can also be armed with rockets, machine guns, missiles, torpedoes, and depth charges, and fitted with modern sonar systems for tracking down submarines. The AgustaWestland AW-159 Wildcat, previously called the Future Lynx and Lynx Wildcat, is an improved version of the Westland Super Lynx military helicopter designed to serve in the battlefield, utility, search and rescue and anti-surface warfare roles. In British service, common variants are being operated by both the Royal Navy and British Army, having replaced their Lynx Mk.789 predecessors. The AW-159 has also been offered to several export customers, and has been ordered by the Republic of Korea Navy and the Philippine Navy. In 1995, the British government announced that the Royal Navy's existing Westland Lynx helicopters were to be replaced. At that point, the service was intended to operate an all-Merlin fleet. Despite this stated intent, Westland Helicopters continued to hold talks with the Ministry of Defense (MUD) to find a future role for the type during the late 1990s. The firm issued multiple proposals to either extend the life of the existing Super Lynx through upgrade programs or more ambitious remanufacturing programs incorporating varying degrees of new components. In 2002, the Future Lynx project originated in two studies to determine the suitability of a derivative of the Super Lynx 300 to replace the existing Lynx helicopters of the Royal Navy and British Army. These requirements were known as the Surface Combatant Maritime Rotorcraft (SCM-R) and Battlefield Light Utility Helicopter (BLUE) programs, respectively. In July 2002, AgustaWestland received a contract to conduct a formal assessment phase of the Future Lynx. On the 22nd of July 2002, a collaboration agreement was signed between AgustaWestland and Thales Group, under which Thales was assigned development responsibility for the program's core avionics, including communications, navigation, and flight management electronics. That same day, additional MOD funding for the fledgling Future Lynx program was announced as having been allocated. By April 2003, the in-service dates for the BLUE and SCM-R programs were reported as being April 2007 and April 2008, respectively. Early on, AgustaWestland elected to adopt a glass cockpit incorporating electronics upgrades from the AgustaWestland AW-101, along with various airframe improvements, such as a redesigned tail rotor and nose, as well as an increased use of machined components over fabricated counterparts, for the Future Lynx. By July 2004, the option of upgrading and remanufacturing the first-generation Lynx had reportedly been judged to be uneconomical, and the Blue program of building a new generation airframe had been given prominence instead. In late 2004, the National Audit Office (NOAA) criticized the UK's existing helicopter fleet as being insufficient. Concurrently, a major reorganization of the MOD's procurement process subjected ongoing helicopter programs to major restructuring. The Blue was reportedly deemed unaffordable, and it was speculated that a more modest sensor fit could be used, as well as the procurement of alternative platforms such as the NH Industries NH90, Eurocopter EC120, or Eurocopter EC635 instead of the future Lynx. Ultimately, the utility transport aspect of the Blue requirement was de-emphasized and the program renamed Battlefield Reconnaissance Helicopter (BRH). In early 2005, the MOD was reportedly deliberating on whether to launch an open competition for other companies to bid to meet the BRH requirement, or to sole source the contract from AgustaWestland to proceed with the future Lynx. In late March 2005, the MOD confirmed the future Lynx as being its preferred option for its rotorcraft renewal program, and was expected to place a non-competitive contract with AgustaWestland later that year. The signing of the contract was delayed to the following year. This was reportedly in part due to preparation and release of the 2005 Defense Industrial Strategy, which supported the selection of the future Lynx. On the 22nd of June 2006, the MOD awarded AgustaWestland a £1 billion contract for 70 future Lynx helicopters as a commitment under the strategic partnering arrangement with AgustaWestland. The program envisaged providing the British Army with 40 aircraft and Royal Navy with 30, with an option for a further 10, split equally between Army and Navy. By late 2007, the future Lynx was scheduled to enter service with the British Army and Royal Navy in 2014 and 2015 respectively. In 2008, the cancellation of the future Lynx program has reportedly been under consideration. In December 2008, the MOD announced that the main contract would be proceeding, only incurring a minor cut in numbers set to be procured, for a total of 62 rotorcraft. In October 2007, following the passing of an interim critical design review, the future Lynx program proceeded to the manufacturing phase. The first metal was cut on the initial flight test rotorcraft that same month. In September 2008, the power plant selected for the future Lynx, the LHTEC CTS-804N, received European Aviation Safety Agency (EASA) type certification, enabling production deliveries to commence. In November 2008, GKN delivered the first complete airframe to AgustaWestland. The new airframe reportedly had an 80% lower part count than the earlier generation Lynx, which was achieved via the use of monolithic machine components. On the 24th of April 2009, it was announced that the future Lynx had been designated a W159 by AgustaWestland, and would be known in British military service as the Wildcat. On the 12th of November 2009, the first Lynx Wildcat conducted the type's maiden flight from AgustaWestland's facility in Yeovil, Somerset. On the 14th of October 2010, the second AW159 performed its first flight. On the 19th of November 2010, a third Wildcat joined the flight test program. In July 2009, it was announced that the cost of the Wildcat program had increased to £1.7 billion. In December 2011, it was reported that 4 additional Wildcats had been ordered for use by British Special Forces. These are to be joined by 4 from the current fleet on order, for a total of 8 aircraft to operate as Wildcat light assault helicopters. Further orders for the Wildcat have since been placed by export customers. including the Republic of Korea Navy and the Philippine Navy. The AW-159 Wildcat is a further development of the Westland Lynx. While the AW-159 shares broad similarities in appearance to the Lynx, it has significant design differences and is heavily modernized and adapted to gain new attributes and functionality. The AW-159 comprises 95% new components, the remaining 5% consisting of such items as the fuel system and main rotor gearbox, are interchangeable with the Lynx AH-7 and HMA-8 variants. During development, the Army and Navy variants of the Wildcat reportedly maintained 98% commonality with one another. The AW-159 is the first helicopter by AgustaWestland to be designed inside an entirely digital environment. Among other changes, certain external elements of the Wildcat, such as the tail rotor, have been redesigned for greater durability and stealth qualities. Both Army and Navy variants have a common airframe, which is manufactured by GKN Aerostructures. The airframe has been marinized for operations in the naval environment and provides for a greater airframe lifespan of 12,000 flight hours. The wheeled undercarriage is also strengthened for naval landings on both variants. The AW-159 is powered by two 1,362 horsepower, 1,016 kilowatts, LHTEC CTS 800 turboshaft engines, which drives the rotorcraft's BERPIV rotor blades via a new transmission, increasing the maximum takeoff weight by more than 1 ton over the legacy Super Lynx. It is equipped with a new composite tail boom, tailplane, tail rotor, nose structure and avionics suite. The naval version is also equipped with a Celix Galileo Seaspray 7000E active electronically scanned array, AESA radar and L3 Westcam MX-15D electro-optical infrared nose turret. A glass cockpit comprises the primary human-machine interface, using four 255 by 200 mm multi-function displays to provide information to the aircrew and interact with the avionics systems on board. The Wildcat featured an increased payload and range over the preceding Super Lynx. It is operationally required to carry up to 8 future anti-surface guided weapons up to 185 kilometers from a host ship and remain on station for up to an hour. The type can perform aerial reconnaissance, anti-submarine warfare, ASW, anti-surface warfare, ASUW, utility, fire control, command and control, and troop transport duties. In these varied mission roles, a range of munitions can be used. In June 2014, the Royal Navy awarded Thales Group a £48 million contract to deliver the lightweight multi-role missile, Martlet, for the Wildcat under the Future Anti-Surface Guided Weapons Light (FASGWL) program for targets such as small boats and fast attack craft. A Wildcat can carry 4 launchers, each with 5 Martlets. British Army AH-1 with 0.5-inch, 12.7mm M3M heavy machine gun. In March 2014, a contract was awarded to MBDA for the Sea Venom FASGW heavy missile for use against vessels and land targets, replacing the Seaskewa. Both missiles are being integrated by AgustaWestland in a single £90 million program by 2018, with IOC for both planned by October 2020. Many elements of the AW-159's avionics are provided by Thales Group. The type is reported to possess significant ISTAR capabilities and improved situational awareness, achieved through its onboard integrated digital open systems architecture. It has been equipped with the Bowman communication system, allowing for data such as targeting and voice communications to be securely and seamlessly transmitted to friendly forces. Some AW-159 models have been fitted with various General Dynamics built mission systems. These include secure data recorders and tactical processing systems which integrate sensor data and application information for displaying within the cockpit as well as for retention within encrypted data storage. Other mission systems used on the Wildcat have been produced by BAE Systems. All variants of the Wildcat share the same defensive aids arrangement, which shares some commonality with the AgustaWestland Apache. Features include missile warning sensors, countermeasures dispensers, and infrared exhaust suppressors.